Hello everyone, and I welcome you all to this video lecture on how to design Turing machine for a given language. That language is Turing machine for L equal to a to the power n, b to the power n, c to the power n, such that n greater than or equal to 1, okay, over the language set, that is sigma equal to a, b, and c. Now let us see how we can design Turing machine for this particular language set. Now first of all, we have to identify the language set, that is L equal to what and all are the possible strings that pertains to this particular language. That is, it can be ABC, it can be AABBCC, it can be AAABBBCCC, and so on. Now this is the language set we got as per the given language. Now let us see how we can design Turing machine for this particular language set to accept strings pertaining to this language set. Now, as we know that Turing machine will have a tape associated with, and tape is once again associated with a tape head. Okay, something like this you can imagine a tape head which will have n number of cells, and by default all the cells will be blank. And if at all we want to test a particular string which belongs to or which is accepted by the Turing machine or not, for that we can take some strings and we can write something like this to test it. Now tape head by default will start from the first string. Okay, this is tape head, and we know that tape head will move either right side or left side, one cell at a time, and this tape head has capacity of reading or writing strings onto the tape. So that is the overall gist of Turing machine. I just recalled it for your convenience. Now let us design. So Turing machine will initially start from the starting state. By default it is Q0. Now let us take one string, that is, I'll write here A, B, 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 C, C, C. Now let us assume that this particular string is written on the tape, and there will be several blanks here, and here also there will be several blanks. Okay. Now the logic is what we do. The tape head starts from the first symbol. Okay. Now what we do is whenever we encounter A, there is a pattern actually, A to the power n, B to the power n, C to the power n. Okay. So we are not supposed to alter the pattern. So whenever the Turing machine encounters A, it overwrites that cell by X, and it moves to the right side. So while moving to the right side, whatever the number of A's it gets, no issues. Let us ignore it. Okay. Then, if at all it comes across another symbol B, okay. Now here, what we do is we override this particular cell by Y, and whenever it comes across A and it writes X, it will be in state Q1. Initially, it will be state Q0, then it comes to Q1 because it has now dealt with A. Now, whenever it comes across B, it moves to another state, that is Q2. And it stays on Q2 until it comes across C. So, whenever it comes across C, okay, it replaces it by Z. And this time, it doesn't move to the right, it moves to the left. And it will be in state Q3. It moves to the left until it comes across an X. So this forms a loop, and the same story continues. Once again X, once again Y, once again Z, comes back, once again Y, once again X, once again Y, once again Z, comes back until it clears all the symbols. Okay, and we will have to put the stopping condition for this particular iteration or recursion, whatever we call. Now let us see how we can realize this particular logic using state transition diagram. Fine. Now the Turing machine is in state Q naught. This is our starting state. Okay. Now we have taken the string that is A, B, C, and there are several blanks. Okay. Now Q naught, upon Q naught, on being state Q naught, Turing machine, when it reads the first symbol A, this is the notation. I hope you remember A. A is the symbol red. Okay. It replaces that A by X and moves to the right. That's all. When it replaces that A with X and moves to the right, it goes into the state Q1. Okay. Now on Q1, state Q1, if it reads any number of A's, it will stay on the same state and it doesn't do anything. And the tape head moves to the right. So it scans all number of A's. Now when it comes to B, that means when it encounters B, it changes its state. Okay. So B, now this B will be replaced by Y, and again it moves to the right. Now it changes its state to Q2. Now once again, on Q2, the Turing machine may read any number of B's. Okay. So the tape head moves to the right. Next onwards. Now that can be represented like this: B, B, right. So it moves to the right. Now when it comes across C, once again it changes the state. Okay, that is C, Z. But now this time, as I told you, instead of moving to the right, it comes to the left. So the symbol is L. Okay, I just extend this, and it moves to the new state, that is Q3, and it puts a Z here. Okay, it puts a Y here. Now when it comes towards the left, okay, it may encounter several B's. Okay, that we can write like this. It may encounter several B's, no issues. Ignore it, just read it and come to the left. It may encounter several Y's, no issues. Come to the left. It may encounter several A's, no issues. Come to the left. Okay. It can come across X at some particular moment of time. So then what we are supposed to do is we are supposed to bring it back to its initial state, that is X, X, R. So when the tape head comes here, we are supposed to bring it back to its initial state. That means in this state, once again it reads A because it is shifted to right. So now the tape head will be here. Okay. Now, few fine tunings we are supposed to do. That is, here we could put it like that. Okay. Now, once again, see, when this C is made Z, okay, this C is made Z, and when it is coming towards its left direction, it may also encounter several Z's. So we have to ignore that. When there are multiple C's, it may encounter. That means in this particular state, Q3, it may encounter several B's, several Y's, several A's, several Z's. No issues. Just make the tape head move towards its left until it encounters X. Okay. So when it encounters X, it comes back to Q0. This is a loop. Now here, when this is the case, when it reads first or any A upon Q0 state, okay, it replaces it by X and moves to the right. So when it moves to the right, it may encounter several A's, okay, it may encounter several Y's. When it encounters a B, then only it changes the state. Otherwise, it doesn't change the state. I hope you understood. Now here also the same case. When it encounters a B, okay, here when it encounters a B, it changes its state to Q2, and here it may come across several Y's. Okay, so it is Y, Y. So now, yeah, this is not Y Y R. This has to be Z Z R. I'm sorry for that. Z Z R. That is, when it moves towards for finding occurrence of C, it may come across Z's. So that will be ignored. Whenever it reads C, then it replaces that C by Z and it moves towards left direction. So that is the correction. Now, when all the strings are made as or overwritten like this, that means the strings become blank x x x y y y z z z and any number of blanks. So this will be the final status of the tape head, tape of the Turing machine. Okay. Now the Turing machine will be in state Q naught. When all this happens, Turing machine will be in state Q naught. Now upon Q naught, we have defined only for reading A. Now see, the tape head will be here and the Turing machine is in Q naught. But now it is reading, it is about to read Y. We have not defined any transition for reading Y. We are supposed to do that. That is, upon reading Y, okay, on this state, upon reading Y, keep it as it is and move towards right. So it moves to the right. So when it is on its journey towards the right direction, it may come across several Y's. Several Y's. Okay, so it continues. So when it comes across Z, no issues. Let it continue. So this is Q4. Okay, Q4. So when it continues upon reading Z, okay, and one fine moment it comes or it encounters a blank. That is blank, blank. And it keeps that blank as blank only. It doesn't do anything. And here we have a freedom that either we can ask the Turing machine tape head to move towards right or left. I will make it right. Okay. Then it moves to the final state. And here also you can show if you want B B. This is not required. This is not required, but you can show it if you want. Otherwise, you can skip this and put it as a final solution. So this is a solution for language set L, that is, which defines a to the power n, b to the power n, c to the power n for such that n greater than or equal to 1. I hope you understood. This is one part of your solution. So those who are appearing for video exams, this is one part of your solution. And there are two parts. This is state transition diagram. This is state transition diagram. And the other two parts are, I'll write it over here, just for your reference. Okay. That is instantaneous description, and the last part is transition table. So all these carry equal marks, wherein this carries little less marks. These two carry a good weightage marks. Yeah, welcome back. So one part of the solution we have seen with respect to designing Turing machine for the given language. The second part I was discussing in my previous video, that is how to write instantaneous description, so-called ID. Now let us take one small string, that is AABBCC. Sometimes in the question they specify, write instantaneous description for so and so string. Sometimes they won't specify. In that case, you are supposed to assume that I am going to write instantaneous description for so and so string. Now, for our discussion, let us this be the string AABBCC, which belongs to this particular language. Okay. Now, how to write? Now, as we know, initially Turing machine will be in state Q naught. Okay, Q naught, and let us take the string AABBCC. Okay. Now, that is one notation for instantaneous description. That is this one. Okay. Now, upon reading A on Q naught. Okay, what it does, it makes or it overwrites it as X and it moves to state Q1 and remaining symbols remain as it is. Now that means Turing machine is in this particular state. Okay. Now in this state, if at all it reads A, it doesn't do anything. If at all it reads Y, it doesn't do anything. So it continues. So X, A, Q1, B, B, C, C. Now see, it is about to read another symbol, B. So it changes its state. Okay. That is X, A, it goes to Q2 and it replaces that B by Y. So this is the instantaneous description. Let's move on. Okay. Now you can start from here. You can write like this also. No need to go horizontally. You can go vertically also while writing the answers. Now once again it is reading B, so no need to do anything. X, A, Y, B, Q2, C, C. Now see, it is reading another symbol that is C. Okay, so it changes its state to Q3. That is X, A, Y, B. When it is reading a C, it moves to Q3, but it replaces that C by Z. So Z, Z. Okay, now see, one more thing. When it reads a C, it doesn't make a right movement, it makes a left movement. So it is in Q3, okay, Z, C. So try to understand this difference. It was here, okay, it read C, it made it Z, but it came to the left. Okay, so yeah, that's all. Now it is coming back. Okay, while coming back, it may encounter several Z's, several A's, several Y's, several B's, no matter. So X, A, Y, Q3, P, Z, C. So you can go on writing like this: X, A, Y, not Y. Now it is making left transition. Q3, Y, okay, Q3, Y, P, Z, C, and comes back X, Q3, A, Y, B, Z, C. Okay. Now, after this, I write it here. Okay. It is Q3, X, A, Y, B, Z, C. Now this completes one full loop. Next onward, the same thing you are supposed to follow. So this runs until all these symbols become or replaced by capital X, capital Y, capital Z. So one fine moment, it will be like this. When you complete all the loops, it will be Q naught, X, 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 Y, 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 Z, Z, Z. So Q naught will be here, sorry. Q naught will be here. Okay. Then you can plan for this terminating transitions. So I hope you understood this